and Asia for Horizen Labs, which is the builder behind ZK Verify. So we're relevant in this panel because we are ZK-proof verification layer, currently on testnet, going on mainnet soon. So very excited for this panel today. And myself, just before this, I spent the last 2 years at Exchange, where I met a bunch of people across the industry. But yeah, okay, that's it from me. And Deli.
Yeah.
Thank you, Maggie.
Thanks, Gwen. I'm Deli from Automata. So we're actually building since 2021. So we have been working on a technique called like the trusted execution environment, or TEE. Okay, let me try again. Okay, yeah. So what we've been doing is actually making things verifiable. Yeah, I have to take this one. So making things verifiable using the capability from hardware, essentially the same route that most of the even like traditional companies has been taking, right? Apple has been doing like enclaves on your phone. They are also doing like cloud-based inference, but also running in TEs. So I guess that's why we're here today, really talk about how we can empower the AI agent with more verifiability and autonomy. Yeah.
Hi guys, I'm Josh here. I work on EZKL, so the company is called zConduit. So EZKL acts like a compiler for AI models into ZK snarks. So you can essentially prove the inference of AI models. And it's kind of useful for a lot of purposes because now you can verify AI models on chain.
Hey guys, my name is Maggie, and I'm with Zypher Network. I'm on the operations side, and I think I'm probably the only non-technical people here.
I'm not technical, just say.
Okay, so I'm humbly happy to be here because our project is probably the youngest and with the least people. But I think we're really building something cool, that we're building a ZK computing layer for trustless AI agents. And right now we have 2 core products, Proof of Prompt, which is a ZK TLS-based solution for prompting process, and also Proof of Inference, which leverage circuit-based models for smaller models. And beyond that, we have an entire ZK stack to support efficient verification for the ZK proofs that we use, including a gasless layer 3 optimized for ZK proof verification, proxy protocol for the ZK TLS, and also a decentralized DP network for distributed ZK proof generation. Very excited to be here. Thank you.
Yeah, thanks for that great introduction. Hi, everyone. This is Michael from Brevis. You probably already heard my talk this afternoon. So just to quickly recap, Brevis works on ZK verifiable computing. And right now we have 2 main products. One is a on-chain ZK coprocessor, where you can use to allow your smart contract to have access to arbitrary historical on-chain data, such as transaction events and states, and build very fancy, new intelligent DeFi features and many other features using these data to do arbitrary compute. And more recently, we launched the Pico, which is an extremely high performance and modular ZKVM that support arbitrary kind of a computation capability, and also with like enshrined app level coprocessor to even make the developer experience to build like on-chain data access the product even easier. On the AI front, we actually built something called SPA ZK. So what it does is that it allows you to transform a model that is very hard to compute in ZK and to something that is very easy to actually generate ZK proof for. And we would love to, be happy to talk more about that during the panel. Yep.
All right. So my name is Nick. I am the founder and CEO of Fuel. Fuel is a competitor stack to what you see out in the space. So we have our own virtual machine, our own language, our own tooling, completely built from scratch, and it tries to bring the best of all of the existing architectures you see into a single architecture, a single unified architecture. We have our own layer 2, our own sequencer, our own economic model, and right now, in terms of like, if you just want benchmarks, most recently we did a benchmark on trades per second that we can accomplish. And on an M4, we can do 400,000 trades per second. So it's quite a lot of power, just depending on how you want to use it. But the core idea is that I've been building on, Ethereum and most blockchains for, well, at least Ethereum almost since it started. And a lot of things were not designed very well. And I think that we have a moment of time left until we can design things in a better way before the entire world starts using blockchain for everything, and it will be too late to switch most of this stuff over. So, yeah.
I mean, are you really sure that we'll use blockchain for everything?
Not for everything, but they'll use it for so many things that I think, especially with AI or ZK as well, that I think, I think we should dream big about how this is going to go. Yeah.
Yeah, I think that is a whole different panel as well. But
probably.
Yeah, so I'm sure some of us here have different opinions about how far Web3/blockchain will go. But I just want to get a sense of the audience here. I know we've had some switch outs. How many of you here are technical? Oh, some minority. Okay, and the rest of you, I'm assuming everyone is in Web3 or who are new to Web3? Like the last 6 months? 0. Okay, great. So I want to make this as interactive as possible. So even though I'll be leading this discussion, I'll be asking some questions, both general and maybe specific. But I will encourage all of you, if you have questions, feel free to raise your hands. And I'm sure we will get a mic to you by one of the amazing Brevis staff, right? Michael, I'm sure your team will come up and rise up to the challenge. So let's get started. Earlier we talked about decentralization in the previous panel, right? And when we talk about we look at the entire landscape, you're looking at tokenization of agents as an example. When we go into the AI stack and when we look at the future, yeah, sure, this panel, we think that AI and blockchain and ZK specifically works hand in hand. But really, where does verifiable computing play? Like, why are you so opinionated about this future? Anyone can start.
Okay, I'll take a stab at this one. I guess the way I would put it is sort of like this. Right now, with most of the AI that's happening, and again, I'm not an AI expert, more of a blockchain expert myself, but when it comes to verifying whatever the hell the AI is actually doing, or as well, potentially using AI agents to do things on chain, I think you want some level of data or proof that this model did certain things against certain data sets. And I feel like it's probably a really hard challenge to actually get right in terms of verifying all the computation. But I do see sort of a massive intersection between AI agents doing things for people and probably taking up most of the transaction data on blockchains in the future. And then very much, I think AI playing a pretty important role even in verified computing, depending on how it goes. For me, my preference would definitely be TEEs over doing it with ZK. I think doing it with ZK seems a little crazy, but I'm sure it's possible. It
can be complementary.
It could be complementary for sure. I just don't know, but intuitively, I feel like TEEs would maybe be a little more appropriate. But regardless, I think those kinds of things make a lot of sense to me, because right now AI is very much a black box. Like, you really don't know what they've done. Yeah.
I'm going to throw you maybe a tomato from the retail audience. Like, do the average audience care? If you look at just Web 2, I mean, here over Web 3, I don't think they care.
I don't think average people need to really care. I think it's going to be more businesses or money managers or these kinds of people that want to know how AI was applied to make decisions on their behalf. And that's where you want more evidence of how it actually functions. So I think, honestly, most retail people, what they're worth now is just whatever money they have times whatever attention they can create. And AI agents are more, they can do a lot of things, and they'll be able to do everything a human can. So an AI agent, you very much want some level of verification, I think. For certain things, yeah.
Yeah, so let's go to Maggie, because Maggie, Zypher specifically, you focus a lot on gaming, right? Which is, I think, a very obviously a very traditional / Web 2 space, which is a lot of, I guess, I want to link it to Nick's point, right? Can you share about what the work you do at Zypher, a little bit more detail, and why does, again, verifiable compute matter in that space?
Yeah, so gaming was something that we focused like 2 years ago. Back then, we were launching a lot of fully on-chain games and verifiable games, which means that for fully on-chain games, it's like we put everything on-chain in smart contract, but we use ZK for certain mechanisms that is very important in games like Fog of War or shuffling. Like, you don't want to show your card for anyone on-chain because we were building everything on-chain. So every card is built as an NFT. So when you give, like, if someone's giving me a deck of cards, I don't want the opponent to see it on-chain so he can front-run my strategy in the game. So specifically for us back then, doing game integration was making us a lot of money. We were making $500,000 in revenue just doing game integration, and that also get us like maybe around 1 million participants in addresses. So back then, for us, it was very profitable, and doing a lot of gaming is kind of a natural choice. But this is a little bit off topic, but like gaming isn't the favorite of the market over the last year or the last 2 years in terms of the token performance or financialization, and people are not that incentivized to play the games, which is also a point where we figured out that there might not be as many on-chain gamers to play the games, but you can have a lot of AI agents to create content in the game. Because the game that we had in mind that I envisioned was kind of very much like the autonomous world, the concept that people were talking a lot about 2 or 3 years ago during the Dark Forest launch, or even longer. That was like, you can build a fully on-chain game where the game is kind of DeFi-like. You put everything in smart contract. Every move in the game is recorded as a transaction. And the reason that we kind of tap into ZK or build verifiable tools for that is because in games, like gaming is such a complicated type of application. It's an epitome of complex application that there's so many state transitions. There can be like maybe 60 state transitions per second or per minute, and you don't want to record that as transactions. So we do that off-chain and aggregate all the state transitions as like one proof on-chain and recurse the proof. So for every like 300 moves that you have made in the game, you only make one transaction, and we can do wallet abstraction to even reduce the amount of the actual interaction with the chain. So this is kind of the reason why we built the game at the very beginning. And like mentioned, we figured out that AI agents, if we give them a very good playground in the fully on-chain games or verifiable games, that everything is, like you can see that on-chain, there's no backdoor for any of the AI agents. Like they can just evolve themselves, and you can see some very interesting solutions. And for us, that is specifically very helpful when it comes to multiplayer games, because sometimes you don't get enough player at the same time. So we need to help the gamers with matchmaking to help them basically increase the experience of the game. So like this is how we kind of tapped into the AI agent space. But also one of our co-founders has been building digital human or virtual human for 10 years at Baidu, so he had a lot of experience in there. And I think gaming is kind of an example experience or example application of why we build things on chain and why like verifiable AI agent is important. Just going back to your earlier questions, I think like today's AI agents that people see is kind of within the imagination. Like you see a chat box with ChatGPT, but when ChatGPT was launching the operator canvas, like there's the process that it can help you order something from DoorDash, but when it comes to the point where you need to pay or make a payment in the order process, like it's actually interfered by a human, like you gave him your DoorDash account, or you don't want him to know your DoorDash account. So I think like when it comes to financially critical, mission critical tasks on chain, like you don't want to just trust the AI agents, you want the proof that this process is trustworthy. So I can let you trust with my money, and I can give you maybe my identity or whatever you need.
So both Nick and Maggie, you mentioned something, an overarching thread, which is a theme, which is money, right? You talk about money managers, and for Maggie, you mentioned games, and I would imagine those are, where games where money is really at stake. There'll be more applications there. But I wanted to move to Deli. I'm sorry, the sequencing is messing me up. So Deli, what do you think of Nick's? How do you respond to Nick's comment about TEE? Because you do a lot of TEE stuff, right? Yeah.
I think he was right, actually, because on most of the workload right now, you probably have to use TE, and ZK couldn't really do it, especially given the size of the large language model. It's like 600 billion parameters. By downloading it, you take even like maybe 1 terabyte of your disk space. So essentially of course, TE is also a verifiable compute technology. And I would like to give us some very concrete examples of why it's important for LLMs. Also, it's going to be related to like everyday use case as well. It mainly solves one issue actually. It's a trust me bro issue. Imagine nowadays all the LLM providers, they're just overcharging you by serving you actually less powerful model, but you don't really know what's the difference because as an average user, you probably can't really distinguish between ChatGPT 4.0 or 0.1 or 0.3. To your use case, most of the inquiries you send can be handled by any of them, but then you're getting charged maybe $200 per month, and you don't know. It's essentially a fraud, right? So this is one of the trust me bro issue. Second trust me bro issue is maybe someone offer you free API access to LLM, but essentially you don't know that you're already giving out data, and probably they're collecting your data and try to train the model based on your input. So verifiable compute could also solve this kind of trust me bro issue because you will know that the model is not making any wrong thing. They are not collecting the data. You know that your data is only used for serving the request, but after inference, everything is deleted. So this will be useful use cases that verifiable compute can provide. Yeah.
Can you share more of the specific use cases that that Automata enables?
Right. So I think one of the fundamental thing about AI agent is how are you able to verify? Like, say, if you're already running things in TE, how are you able to verify it? Another extended question is how are you able to verify it publicly? So that's why we're building an on-chain stack to verify all kinds of TE workload, including the inferences. So nowadays you're already able to run maybe your own large language model, maybe a 70 billion model inside a H100 NVIDIA GPU card on your own machine or someone else's machine. With TE. So that basically gives you a guarantee that they have a black box that you can verify. So what we're doing is we bring the proof of that someone running the verifiable black box on chain. So anyone can go ahead and check the proof and claim that or verify the claim that this is a real setup, that they have this kind of GPU card with a specific model running. And you can also trust that your data being sent over there is not taken for other use, and also your response getting from the model is also correct because it's really produced by that model or instead of other less performant models. So
Joshua, EZKL, how do you pronounce it again? EZKL, sorry, EZKL, that's better. You are an open source library for ZK and ML models. Can you talk through about how you're playing in the space a bit more deeply, especially connecting to Deli's point?
Yeah, I guess one, in terms of the space-wise, ZK tough, ML tough. So when I tell my mother I work in ZK, she's like, I have zero knowledge about what you're doing. Are you jobless? And I'm like, it's tough. So I think communicating more about this space is important, right? So because at the heart of combining ZK, AI, blockchains, you're trying to solve a very, very boring problem, which is accounting. So ZK, blockchain, AI, sexy. Accounting, not sexy at all. So you wouldn't expect a child to wake up and say what do you want to be when you grow up? And then she's like, I want to be an accountant. But essentially this is what we are trying to solve. And think about accounting, right? Like the root of accounting is trust. How do you like account for what assets are in what place? And then how do you commit to that? And so ZK is useful because like now you can turn this commitment instead of like a trust me bro, it's now like a commitment scheme in polynomials. So it's like a mathematical receipt to say that, okay, this is what I committed to. You can calculate this and you can use this receipt for something else. So I think it does open a bunch of use cases on chain. So I can talk more about it in terms of what we have been doing. But so far we have been seeing a great amount of pull within the DeFi sector on how can you calculate parameters in a more trustless way. Do you want to hear more about the Z? Okay, sure. So in terms of the DeFi space, the one project we have been trying lately is to calculate LTVs. So LTV stands for loan to value. So you want to ensure that the protocol parameters would ensure that everyone is solvent. Like you don't want like a DeFi protocol to go bankrupt. So for protocols like Compound Aave, this LTV parameter, if you dig right into it, it's basically a DAO proposal. And who makes the proposal? It's basically Gauntlet. So it's a bunch of like Taran like doing a bunch of math in here, 17.5% accepted. So this is what has been happening. So suppose like the trusted parties, like at some point people will retire. So if you want the system to operate normally as it would and to reduce like the friction between a transition process when you migrate to different DAO members, you might want kind of an accounting mechanism for that. So like everyone who's using the protocol won't be bankrupt. So this is one use case which has been quite helpful. And when you turn it to an AI model, it can be way more dynamic versus one fixed parameter 17.5. It can vary based on like market conditions. And you can prove them with like maybe not so complicated AI models, but things like classical ML models, which would be also quite useful and more understandable. I hope I'm not taking too much time.
You can take time, for sure. Anyone has any response to that? I think, Nick, yeah, you mentioned money, DeFi. I would love your opinion on that.
So I'd be really curious to know, so just on a cursory level, you're saying that you're combining machine learning and ZK, right, together, and then you're producing a ZK proof based upon what the model is doing, right, which you can then prove on chain. So how complex could that really get? Because, I mean, already ZK is pretty horrible with the polynomial proving already, so I can only imagine if you add in all of the work from machine learning, kind of how bad that actually is. Like, I'd be very curious to know what it's like to combine both of those, because the reason why I just gravitated towards the TEE is it's basically just an attestation. It's like, an execution attestation from Intel or AMD that like this chip we made did this proving and it worked this way, which is pretty easy for me to work with. It would be amazing if it was all ZK, because then I could just like prove to Ethereum without the middleman, like, hey, this is great. But how complex can the machine learning get with your ZK, approach? I'd love to just know more about that.
Okay, I hope I will not go into the boring weeds. But how it works is that most AI models are a kind of computational graph, right? So it's like a tree of computation. And ZK, when you talk about ZK, I was talking about arithmetic circuits. And they're also a computational graph, so it's kind of like a tree. So you get that one, so the idea is that you get the one tree from AI and turn it to the other tree. So that's where the magic happens. So there are a bunch of tricks that needs to be done to make that tree compatible with this other tree itself. And so you can compute in this system. But the TLDR is that in order to make this tree, there's like a specification which is kind of useful. It's called ONNX. So it's an open specification which most AI libraries are using, TensorFlow and PyTorch. So you use that. do whatever you want to do, like the training, train the model, and then you just simply export it out. It's an evolving specification, but so far I think we are able to get all the official specifications handled for. So if you use like all the official specification Onyx, it would work. But so far, when I've been trying out like the recent Hugging Face models, it appears that they came out with like new specs, and so we are kind of catching up with that. But otherwise, it basically works with everything. And so you have a mathematical expression you want to write. You can just basically express it in like PyTorch easily or JAX, which is just like mathematical equations, and then export it out to Onyx, and that's all. Oh yeah.
Sorry, but this is very, very interesting. Or at least it is to me. Maybe for the audience too. The reason why this is so interesting is just because it really sucks to have things happen in computation that you can't prove to a blockchain like Ethereum, basically. So it's like, it's kind of, when you do TEs, it's like Intel or AMD is signing it and saying like, we did this thing. But with ZK, it's more like math did this, and we can just show that to a blockchain, and then it just proves. So to the point of asking about the AI meets the ZK thing, it's very interesting, just in the sense that if you can do AI models, but make them into a ZK circuit, then you can at least prove with this input and this model, I should be able to show, right, that this is the output that it should be, right? Given the data?
Yes.
Yeah, okay, yeah, so that's very cool. Although, how long would it take to prove for an average input, say for like Claude or something else? I don't know. Whatever.
Right, so for LLMs, so it's technically doable right now. But so far, I think like when I'm trying it, I think there are a few caveats, right? If you want to use it for core DeFi applications, like things like LTV calculations, you wouldn't want like an intern who's high on drugs to give you the value, which is basically what most LLMs are. Basically, an intern who is high on drugs. So you get like really crazy results. So and you don't really know why it's like the result. So it helps with like a smaller model. So with the LLMs, like the approach that we have right now is to essentially do model splitting. So you think of like a huge graph, you split it up and you prove by parts and you aggregate all of them together. So it's doable right now. It's just that I think in terms of on-chain applications, I think there are simpler models that we can actually use which are more practical right now, like which can be deployed like in the next week or something, which is the time frame we are looking at.
Sorry, can you explain your intern high on drugs analogy a little bit more, please?
Okay, so I had a schizophrenic intern who was high on drugs. So I'm not sure if you tried using LLMs, and have you heard of this guy called Pliny the Prompter? A raise of hands, who anyone heard of prompt injection attacks? Okay, yes, amazing. So have you messed with an LLM before? So you can really mess them up so badly that they kind of like stop having the safeguard. So you wouldn't want to necessarily trust an LLM, although like it's useful. But once like the trust factor increases and there's so many vectors for them to be exploited, like you kind of wouldn't want to use them for all possible things. But I think it would be useful for some applications. It's just that like for things with a high trust factor, you might not want that to happen. So, like I guess like certain examples, you can trick an LLM into telling you how to produce crack, or like some weird things like how to buy weird stuff on the deep web. So, like the information lies in the data set. And you can also trick an LLM to disclosing some secrets. So those are some things that can be done in practice. So I think alignment and safety will never be solved if you cannot be really impressed. But it's also really fun to see the ways people have been liberating LLMs thus far.
Okay, just a quick pause here. I'm going to ask one more question just to the panel, and I would love for anyone who has questions. Just a quick hand, anyone Show of hands. Anyone has questions so far? There are no stupid questions.
Yeah,
oh,
I mean,
you have
like,
one? Okay, good. Okay, give me a sec. Okay, I'll go to you, okay? Yes, Mike, I wanted to go to
so,
you.
I can ask the question for the audience because, a lot of people actually ask me this question, like, when I was on the stage. So, like, a lot of folks come to me and say, like, you guys talking about verifiable AI inference, are you actually verifying, right? So, like, what exactly is being verified here? Well, I think there's like very, very common, very easily got like misconception here or misunderstanding here is like, okay, verifiable computing means that we can verify the AI's output is correct. That is not verifiable AI agent. So like no one can actually verify that a AI model's output is actually objectively correct. And in many cases, like there's no objective correctness in the AI inference process as well. So what is then, what are the things are we actually verifying when we're talking about verifiable computing or verifiable AI agent? Well, we are actually just verifying the AI did the output from this kind of a black box is actually mapping into a known high quality AI. So that's the only thing, and that's a very, very important thing that we can actually verify using either TE or ZK. So how it goes is like this. In the beginning, you have a model. And someone says this model is awesome. This model is hosted somewhere. It can be a centralized hoster. It can be a decentralized hoster. It doesn't matter. So now the first step of verifiable AI or verifiable inference is to generate something called a commitment. So this commitment you can think of as an ID of this AI model. So you don't actually need to understand like what the exact commitment does. But once that commitment is generated, that means that you can now create something called a verifier to verify all the ZK proof generated by this and only this model. If the model was deviated just by 1 bit, you cannot generate a proof that can pass this verifier. Okay? Now the second step is benchmarking proofs. So you want to know this AI is actually pretty good. So let's say this AI can help you to prepare a bar exam for attorney tests, like a lawyer test in the States. Right? So then what you do is that you ask this AI agent to say, okay, I need to know if you're good. So this AI agent will just generate a proof showing that it can pass bar. And then you can verify the proof easily. At this time, you don't know anything about the AI model except for that ID and also the fact that it can pass bar. And then you say, okay, this is good enough for me. I'm a law student. I can actually work with this AI agent. I can pay for this AI agent. Now you ask a bunch of like lawyer questions for this AI agent, or like if you're fighting a criminal case, you want to ask the advice for this kind of a particular AI agent. Now you're entering this black box interacting phase, like the trust bro problem now arises. Now you don't know whether the thing that is answering your query now is still the thing that passed the bar. So now you can actually challenge the AI agent occasionally. You don't probably need to do it like all the time. You just challenge the AI agent occasionally and say, hey, how about you prove me this output is actually from this awesome AI agent that can actually pass the bar exam. Now the AI agent can just generate a kind of a ZK proof showing that, hey, I'm actually still the guy that you trusted in the very beginning. So this is like what we're dealing with, like in terms of AI agent verification, verifiable computing for AI inference. So yeah, I just want to kind of provide that context for many of the audiences here.
Yeah, I appreciate that. Maybe before we go to that gentleman, can you also maybe, Michael, describe in layperson's terms, TEE and ZK. I know Nick had a one sentence, but if you can explain to the crowd.
Yeah, I mean, like, I think it's just TE and ZK, they both carry additional overhead, and it's a different trade-off space, right? So, like, for TE, it's not that if you use TE, you don't incur any additional computation costs. It's not that. You still incur a bunch of computation costs, and you're trusting Intel. And, we have known, like, in many of the use cases, that's fine. Like, let's say if you want to, like, verify if a response generated by OpenAI is good enough or not, you probably can trust TE because, like, you're almost semi-trusting OpenAI already, right? So, like, if they want to kind of operate on a very mission-critical task, you add that with, like, SGX proof that's good enough, or, like, SGX is not popular anymore. Like, there are many new things coming out now. But if we're going into a decentralized AI future where the hosting of the model is commoditized, and everyone can host the model, everyone can train their own AI agent, everyone's AI agent can serve with each other's AI agent, we enter this like very amazing future where you can actually create AI agent nations. This is where verifiability really matters, and you don't want to kind of have your verifiability subject to potential hardware issues. So this is where I think ZK trade-off space really shines in this kind of a fully decentralized and fully democratized AI state. So yeah.
Yeah, I'm very excited for this nation state. Let's go to that shortly. Yes, we had one gentleman first. Can someone pass a mic over? Victoria, thank you. Or do you think you can shout? No. No, Victoria's coming over with the third mic. Yay. And after that, the gentleman behind, yeah?
I'm not a technical person, but correct me if I'm wrong. So from my understanding about ZK is more about issuer and verifier. So who is the issuer during the model training in AI stuff?
Who's the issuer in the AI models?
Yeah, so because from my understanding is someone issue a credential for someone who need to verify the credential. During our conversation, it's more about the verify style, but who is the issuer about the CK part?
Yeah, well, I can explain that. So I think this comes back to how ZK proof really works, right? So for ZK proof, let's say you're trying to compute x plus y equals z. This is like the compute you want to compute. Without ZK, the only y, if you have x, y, and z, these three numbers, if you want to know whether x plus y actually equals z or not, the only way to do that is to redo the computation. Like you do the x plus y computation and then find out if it is z or not. Right? But what ZK allows you to do is that if someone wants to convince you x and y are actually, z is actually the sum of x and y, you don't actually need to redo the computation. You just need to verify a proof. Now, the proof is not the signature, so there's not like a signature scheme where you have an issuer and you have kind of a signature verifier. It is actually a mathematical proof where a prover can just compute the result, but at the same time compute something called a ZK proof. So how the ZK proof works is that you can essentially make that x plus y thing to something called a ZK circuit, and then compute like a very, very succinct proof that can be easily verified. And then you take that proof and bring it to some other verifier that the verifier doesn't need to actually do any computation and verify the result. So, the x plus y is a very, very simplistic and oversimplified example, right? So you can actually plug in any kind of computation that is of arbitrary complexity there and generate proof of the same size, whether you're computing x plus y or you're computing a very large language model with 5 billion parameters, you're generating the proof with the same complexity to verify. So that's kind of like the beauty of ZK, that you compress the computation itself to something that is extremely easy to verify. So in that verifiable AI agent use case, the issuer of the proof is just like the model host. Whoever hosts the model will also be able to do some additional computation to generate the proof, and then give you the proof, so you can very easily verify it without knowing the model or rerun any kind of the computation. So yeah.
Does that help clarify the complexities?
Just one more question. Is the computation more like a protocol, or whether it's based on the company who creates that product?
So the decentralized, the verifier side of things, like the middle, the verifier. I think we need to explain a verifier.
Yeah, I think Joshua can probably answer this better than me. So
in a more layperson way, Joshua, thank you, because I know you're very technical.
Yeah, okay, I understand that most of the audience is not technical, so I try not to go into the details. But basically, back to the receipt analogy, right? So, a receipt has a bunch of things you ordered, but you don't necessarily need to know what you ordered to look at the balance, right? So you can think of it as like a way of calculating a commitment. So there are many kinds of commitment schemes. So Right, so one of the common one is this thing called polynomial commitment. So you can think of it as a receipt, but you're encoding in some kind of curve. So instead of me telling you like the whole equation, I tell you that I know this point exists in the curve, and so that's your receipt. So if I know you know that point exists, it means that I definitely would have known like the way of computing that point. I hope this clarifies things. But functionally, like it serves as a receipt that you can use and pass to someone, and that person can use that receipt for something else. I hope that clarifies.
So basically, to sum up, like it's not computation dependent. Like whatever computation you want to do, you can ZKify that computation basically.
We have many questions. That gentleman first, yeah. Can you pass the microphone to that guy? Oh, no? Yeah, the guy. Oh, he was second. But, okay, sorry.
Hi. So, as we know, like AI agents in a Web 2 world also, and so like Web 2 world agent and Web 3 world agent is like how different? Like people asking me that only, like what is the difference? Same AI agents you are building in a Web 3 world in general. So I think verifiable is the thing. But generally, like bigger model which are like 8 billion or 72 billions or what, this size of verifiability is how complex. Once basically there is a complexity to, we need a higher GPUs and all to do these things. And if you want to verify this large number of models, that can be very, I think, very far in the future in general if you want to verify, right? So currently the stage which verify computing is till which number of contexts we are, like which amount of size we can verify actually.
Michael, you need to take that because for Pico.
Yeah, I mean, like, I think, first of all, I think ZKML or ZK-based verifiable AI inference is much closer than you would imagine. So, 1 year ago, the inflation amount, like basically if we do a native AI inference, then we do a ZK, what is like the cost difference? 1 year ago, that was 1 million times. So if you cost $1 to do inference on a native model without any ZK verifiability, without generating any proof, that's $1. If you do it in ZK, it's $1 million. It's like insane. But this year, we're at 100 times. So there are many reasons that thing is kind of enabled, right? So like, for example, some work that we recently did called SPA ZK. So the conceptually how it works, the ZK model itself is quite complex in the, LL models are quite complex because it has a lot of float point numbers, like 3.56 in the weight matrices, and this is like really killing ZK model. So, what we did, we had an insight in our team that is like if you transform this model into something called a ternary network, and this is like actually from the machine learning community. They do this for different reasons. But if you transform this to a ternary network where all the weights are just 1, 0, and a -1, and now suddenly the ZK verifiability of this model become like much better, much better, 100 times better. And there are also like ways you can accelerate the ZK computing process using GPUs as well. So like there are many directions. I know there are like also teams like Polyhydra is like working on something called Expander that's like also tackles this kind of direction a lot. So a lot of different teams in the ZK space is working towards that goal to bring that over inflation within like 100 times. And once I think it reaches 100 times, it really reaches a critical point where you can actually make this thing very useful, including kind of EZKL's guys' work as well.
So what time frame do you think it can be happen? It can be happen in next 1 year or next?
I'm very optimistic. So like I think it's like probably within a year.
Okay, nice.
Maggie, I would love to go to you actually. Web 2 gaming, Web 3 AI agent gaming. Your work, you're talking about in-game assets, right?
Yeah.
Verifiability. Can you talk more and help us understand, like, how can this future evolve to? Like the future of Web 3 AI agent gaming with verifiable compute.
Yeah, so first of all, I'll be honest with you that we haven't done much new gaming stuff since like a year ago, and right now the focus is more on verifiable, like DeFi-oriented type of use cases. Like we have partners that build the AI agents that we provide the verifiability for the prompting process, but they're still using the large language model, just like ChatGPT or other models, and we're only providing the verifiability for the prompting process. But in terms of gaming assets, sorry, can you please?
No, all good, all good. If we go to DeFi, all good. We have many questions, don't worry. Okay, we had a question there, yeah. Thank you, Victoria.
Thank you so much, Tim. That has been very helpful. I learned a lot. I like to bring another aspect of verifiability from a smart contract, hacks and exploits perspective. You know, all networks have TVLs. All the AI agents these days have access to treasuries. They do transactions. So they are prone to hacks and exploits. And most of these transactions these days, you need to verify from the blockchain itself. So how do you see from a network ownership perspective, how do you plan to stop these hacks and exploits? Because our funds are there and the TVL is a huge a target for many of these attack vectors, right? I just want to ask that.
Yeah, so I actually think that's actually one of the best use cases you can think of where applying some kind of AI system to blockchain would make sense. Basically, like, you need some model that's going to understand a bunch of different things that sometimes you can't plan for. And it's probably a model that's learning off of the chain activity itself, right? And so a model could easily detect, just by logic, hey, this lending market doesn't look right. You know, something's off about the parameters of what this lending market is. And what's better about this than formal verification is that formal verification will only tell you, is that my phone? No, okay. Formal verification will only tell you if the model you created is right based upon your parameters very specifically, but formal verification doesn't really learn and evolve, right? Whereas an AI or a machine learning can basically scan the chain, look at an app, tell you, hey, you know what? I think this app is blowing up or something's going wrong, so I'm going to pause it, you know? And it could absolutely do that. It could do that in a few different ways. I don't think it needs to be fully ZK yet, but the cool thing about it is if it was fully ZK, then the app could be autonomous. So no upgrade keys, no multi-sigs, no dev team. Like, the app and contracts could sit there autonomously and be protected basically by some machine learning algorithm. And then if there is an exploit, the machine learning algorithm might be able to advise exchanges and bridges, right? Advise like railguns that you can't move the funds over a privacy mixer, and basically nullify the use of those funds and even bounty them and just say to the hacker, like, everything's blocked, you can't go anywhere, so you might as well give up 1% to us and give the rest back, and we'll give it back to everybody. And you could design the model to do that, basically. So I think, like, that's one of the more practical direct applications I see for AI versus, like, even doing trading. Because even trading and all this other stuff, like, you could probably write some good scripts, like, it could probably analyze markets, but you would kind of suck to trust it because you wouldn't want to trust it just yet.
Just to clarify, Nick, so I just need to read the bytecode of the malicious smart contract, run ML model on that, and if a next smart contract is similar to one of these, pause the network.
Yeah, basically, like, the model could be trained off of both the documentation for that system and most likely the bytecode and other things, and know what regular activity looks like. Similar to your bank, right? Like, your bank knows what your regular activity is, and if you go outside of it, it'll just temporarily pause. Similar in this, it can very well do that. But what's cool is it could probably get ahead and also call out to other services at the same time. So it could probably instruct all of the wallets to pull all the funds, which is like the real decentralized way to stop a hack, is that we all agree that some service can just pull the funds out of a system just in case, but that system is autonomous, right? That's like the true cypherpunk system that you would really, really want, right? And very much so, I think, as like this improves, like these models improve, you could very much like assign that job to this model, and the ZK would prove it, and you would be able to have this kind of advanced monitoring that's like verifiable, yeah.
Makes sense. Thank you.
Thank you. We have one question in front.
Hello, my name is Yuan. I have a question. In terms of the state of our general purpose ZKVM, where are we at right now? So is it like in foreseeable future we can see like we turn all the general compute into some sort of a provable, verifiable like paradigm?
Yeah, great question, and I can take that. You know, I think for ZKVM has made like a significant improvement over the last 2-3 years. And you know, we just launched the Pickle, which is right now the fastest ZKVM on Earth on CPU. Of course, with GPU, things are accelerating, things like coming soon. But I think, to be honest, ZKVMs are not the answer to like things like verifiable inference.
Michael, I'm going to pause you right there. Can you explain ZKVM just again?
Oh yeah,
in
sure.
two sentences?
Yeah. So what ZKVM does is like you have some very generalized compute, and you don't want to write like a circuit. You just like write normal programs in Rust, Go, and then you know we want a ZK system to generate proof of the computation result. And then, you know, we can basically build a virtual machine that is like kind of almost like a real machine that with the different instructions, where your high-level language can compile down to these low-level instructions, and then these low-level instructions will get stitched together. And these instructions are actually specialized circuit so that you can generate like a ZK proof. So you can think of today's modern ZKVM as a specialized instantiation of like the last generation ZK rollups. And in fact, many of the ZK rollups that build specialized ZKVMs are moving towards general ZKVMs to replace that. So, you know, I think in the future landscape of ZKVM is that ZKVMs themselves are going to be the glue in the ZK-based decentralized applications. For ZK dApps, every ZK dApp will be built using a glue and coprocessor architecture. So where the glue itself handles like a lot of scaffolding, handles a lot of input and output processing, basic things, stitching things together, you know, making sure this like input is legit and stuff. But if you want to actually run some very, very hardcore computation, this is where the coprocessor will actually come in. The coprocessor, where we introduce something called app-level coprocessor, this is something that's very new in the ZKVM space, where you're not only just accelerating very low-level things like a hash, kick hash, signature verification, but you actually take a very large bulk of computation logic in the application domain and put that into a coprocessor, and then it's almost like as if you're interacting with a I/O system. So the I/O system handles this kind of a inference task for you, or handles the data access task for you, and get back the result back to the VM, where the VM can glue that result with many other auxiliary things together into a holistic proof. So I think this is how the ZKVM is going to evolve, and I think we're very close to that future. In a 1 year, at most 1.5 year time scope, I will get there. Yeah.
Thank you.
Do you mind passing a mic behind you?
Hi, I'm probably gonna be asking the most stupid question you can find in the room, but with verifiable computing, so from consumer side, what we know about AI agents is that we've used so far, right? Claude, DeepSeek, and GPT. With verifiable computing, those kind of LM, how would they be changing so that on the retail side, we actually feel like, with verifiable computing, AI agents is actually way more useful than before?
I think that's a good question. Of course, every question is good. I just mean because you said that might be a stupid question, but to be honest with you, I think for us internally, we often ask ourselves the same question, especially for myself, I'm more on the ecosystem and operations side inside the team. And we often ask ourselves, what are kind of the product that really has product market fit? How are you going to really build something that people actually want? Because, for example, they're not interacting with the ZKVM themselves. They're interacting with some application. And for us, I think one thing that it's really helpful. It's like if you can build something that is financially critical and like mission critical, financially sensitive, if you can solve that trust issue, like mentioned earlier, like ChatGPT, OpenAI, they were launching the operator, and in the Canvas process is like whenever it comes to a point that you need to input your account information, and here you don't need to actually give your account information. You can just stop the process and do that manually. But you know, like for example, in the next step, if we bring this on chain, like we can build, for example, an extension that you can feel free to give your access to your wallet to this Canvas operator. Like it might be a different name on chain. So basically to streamline and maybe share with the users in the format of some extension to support them with using any of the existing like agents that people are using. Also, I feel like in terms of where we are, where the technology tree is, it's still very early. Like the direction isn't fully decided yet, and we're seeing so many like improvements that are making every day. So I grew up in China, so I read like Chinese AI news every day. There's after DeepSeek, there's a lot of new stuff like the S1 model by Fei Li's team. They're just using $50 in terms of the training fees. And there's the new ByteDance model that was announced last week. There's a lot of stuff that is happening. And for example, on Taobao, you can just purchase some device that can help you run DeepSeek with around $50. So you can control the entire process yourself instead of like you trust like a Web3 project which is claiming that they are helping decentralize hosting the data. You can actually host the data yourself at a very low cost. And for us as a middleware side, like I feel like there's going to be some really interesting projects. One thing that we are talking internally right now is the Psychic product. That because there were some questions that were directed to Michael, like because I'm not a technical person, I don't understand all the details. But for us, like internally, we also have this very similar ZK inference products. And for the ZK inference product, like I think we build the model to be very prompt specific. So then one of the prompt that we are building, we build the inference process to be very prompt specific. So we're making the model very simple and it does only one thing. For example, for the psychic thing, you are providing your birthday information to the agent that is talking to you, and you don't want to publish this information anywhere on chain, for example. And we're taking that process private and giving you a result that only you can know. So I think there's going to be, sorry, time is up. But
no, it's okay. Go on. I will moderate it. We'll take another 5 minutes.
Yeah, so I think there's like 2 or 3 directions that's really going to be there in the Web3 space. The first direction is, for example, psychic or fortune telling. This might be a variation thing, but it's so popular in China. And you know, like people are using DeepSeek to do a lot of like 算命, to do a lot of like fortune telling kind of stuff. I think if we can bring that on chain, for example, we build a Twitter bot to do that, and it can be a very good tool. For example, if Zypher is launching something like this, Brevis is launching something like this, and people are sharing the screenshots like that, just like what Kaito is doing is like kind of a good tool to do user farming, user engagement farming. So there's going to be some interesting product. And the reason that ZK is very useful and only like this type of programmable cryptography technology is useful because you're sharing your personal information. And in China, psychic is like, the rule is like you don't want to share your birthday with just anyone. It's like your personal secret. So privacy in this case is very important. And second thing is the account information use case. Like you want to share your access to your assets or ID information or whatever information with the AI agent. I think in Web2, one of the things that people were talking about is that AI agents, they cannot have an identity because all the identity systems around the world is really human centric. So like blockchain by nature gives a wallet as an identity, and like you can give your, for example, DID proof to your AI agents and give him grants to certain, like creating accounts for you in Web2, for example. So this is also a very interesting use case. And another one that...
Maggie, I'm going to pause you there. Yeah. No, thank you. That was helpful, right? Illustrating kind of more retail use cases. So I will chip in a little bit from a ZK Verify perspective. Actually, I do want to ask this question to the panel, but we don't really have time. But essentially, on our side, ZK Verify, approved verification layer, right? We envision a world where in the future, Facebook, Twitter, they all have to take the check mark, like someone is verified. Even now, you can pay for it, right? Which is your paid verification is a different story altogether. But we are envisioning something like that, where you trust ZK Verify, where the bottom of the tech stack at this point, there's a check mark by ZK Verify, just to put it out there. We want to make it like easily understandable by the users. Okay, last question for everyone, just to close off. Where do you see this future of verifiable computing and AI agents in the next 1 year? We start with you, Deli.
Yeah, it's a little bit controversy. I would say you either need it or you don't need it, because given the speed of development of the AI models, very likely you'll be able to just host it on your device. Then you don't really need to offload, all sorts of compute to some other cloud provider, and you don't need to trust them anymore. So in that case, you don't really need verifiable compute because everything is done on your device. But also there will be much more powerful models with more parameters coming out, and they really need more powerful hardware, even NVIDIA, something that NVIDIA hasn't created. In those cases, yes, you still need verifiable compute because this is the only way to make sure that you're getting what you are paying for.
I'll be quick. So I think, practically speaking on it, and I think we are going to very likely focus on Balancer V3 and Uniswap V4 hooks. Oh, okay. So Balancer V4, Uniswap V4 introduces concept of hooks, and so you can kind of add additional functionalities to a swap. So it's kind of handy. So you can think of things in terms of like capital management products. You can now do it on chain in a verifiable manner. So you're gonna explore kind of like non-degen use case, right? Because now there's so much conversation about meme coins, everything is becoming nihilistic. So you're trying to bring back more structure, I think, to the capital markets in crypto.
So I do think AI is at a point where I personally feel like performance improvement is more important than decentralization at this point. If I were Sam Altman, or if I were some other owner of this large language model, I wouldn't care about decentralization or verification. I might care about my users' data security, but that's already there on the legal terms when you use it. Which is, I think, make what we do very important for the maybe next 10 years. But maybe like a year later, people are still going to care more about how performant the agent is going to be, how performant the model is going to be. But I think in the traditional AI world, there's definitely going to be more agents and transitioning from the model to the agents.
Yeah, so I guess I can only speak to it from the perspective of what I would want to see as more of a user, you could say, than where it's going to be, because I can't speak to the machine learning side or the ZK side as much. But from a more blockchain side of where I think it's very useful. So first, your wallet should be scanning and machine learning everything that you're doing, and then basically detecting if things are bad. So for hacks or preventing hacks before anyone knows it's a hack would be really, really good. So just that alone, if that was running on your phone, that would be perfect. It's probably enough power. But it could also be running in your browser or using an API or something off your wallet. So I think that's the first one I would really like to see, because that would solve an enormous amount of problems. The second thing is using AI to detect when the user is doing something stupid. So most people, when they use crypto, they're either going to do something stupid, or they're going to lose all their money, or they're going to forget something, or they're going to get hacked, or they're going to get exploited. And machine learning is really great at it's probably way more than enough now to be able to just say, don't do that, which is like a huge portion of what crypto probably needs like in this moment. So I'd say that's like one thing. The other thing I want to see is when I go to exchanges, I probably want to be able to describe a financial strategy that I want. So like, for example, I want to do TWAPs until Thursday, and then I want to have different prices and whatever, and turning every user into a market maker effectively. That would be a really good job for an AI, I think. So all across, I think blockchain AI would play a really nice role everywhere, because most of blockchain is not built for humans. It's built for anarchist crypto people who are very sub-niche of technical people. And it's very inhuman to use, even if it looks nice and it's very pretty. So I think that where I'd like to see things go is just the applied use of all of this machine learning, which is really excellent. And then on the verified computing use cases, definitely if you're voting in a DAO, having a verified, credibly neutral delegate that's an AI would be something that like Sam Altman can't promise me. Like he could go in and tune the model tomorrow and mess with it, and then I can't trust it. Whereas if it was a TEE or a ZK model that was hosted separately, I can trust that to be a credibly neutral actor. So I think these are really interesting cases for the applied use of AI, and I hope that within the next few years we'll see it. But there's a huge lack of creativity in crypto, so basically I don't really know. But I am hoping someone does these things. If you're out there, please do this. Yeah.
Yeah. So just to close off, I think DeFi and AI agent combined together is going to be, in my personal opinion, the most exciting use case. For AI and plus crypto in the next year or two. And with that, we can introduce.
Yeah. Thank you so much, Deli of Automata, Joshua from the EZKL, Maggie from Zypher, Nick from Fuel, and of course Michael, Brevis, our host, and my name is Gwen from ZKVMs. Thank you.